Today's topic is iiQWorks, exciting piece of software. It's something that I've been working on for the last 6 months or so, and it's really exciting to come to work every day and use this software. So I'm excited. We're going to go through some introduction of the product because maybe some of you haven't seen the product yet. So I'll do 15, 17 slides or so, something like that. We'll talk about the product, and then I'll show you the conveyor tech example. Some new software. And just a great suite of software. So I'll get started. Well, let's talk a little bit about the hardware. Some of you are aware of this is our newest controller, the KRC5 Micro-2, we're calling it. It's a very small box, 25% smaller, and some of the same kind of things that you see on the Dash 1 controller and just the KRC5. Some of the same interfaces, same I/O board, a little bit different. I/O is a little bit different on this one, but still the 16 in, 16 outs. And better access. Everything, all the connectors are on one side. So here's a little closer shot of the controller. I think a lot of this will look familiar to you. You see the cables at the bottom here are for the smaller robots. This module will go into a bigger cabinet, a bigger module that'll go into the bigger KRC5, the Dash 2 part. Network stuff is pretty much the same. The I/O is a little bit different. These are organized a little bit differently. I think the pinout has changed. And two new exciting boards, at least the top one here, are KUKA AI board. So the KUKA AI board will do a lot of AI functions, vision functions, this type of thing. When we have extra power supply, 24-volt power supply, that's an option, and then the external access here at the very bottom. So that's our hardware. So our pendant's a little different. We have this SmartPad Pro pendant now. Instead of the long portrait mode, we've got the longer mode. Very nice pendant. Just the screen just pops. I think the HMI is fantastic that's here. And that web browser you'll see later, we can run that on our PC also. And same kind of cable concept, wearable parts, not much different than the other pendant in that respect. So we have this SmartPlug, which is an exciting device. So what you see here is the cable that would connect to the same connections on the controller. And then we have this plug with a adhesive back here that would allow you to bring your own device. So the BYOD model, and that's hardware, not beer or anything like that. So we got a Windows model, a Mac model, and then an Android model that you can run those applications on your own device. And I would suggest that you don't run it raw like this. If you drop this on the floor, you'll probably break it. So you probably need a couple of those with some protection, and a fairly fair price on this, so gets you in a little bit cheaper instead of very expensive pendants. Okay, so we talk about the software components. Probably the biggest change that we have is we have this iiQWorks suite of software, and that consists of the Cockpit software. This allows us to have instance management or these different containers. And this is where we get all our software from. So this repository allows me to go to myKUKA.com and download all these tech packages, like the one we're going to look at today, which is the conveyor tech. But there's many others, and some that you're used to. Some have been reworked, some have not. They're the older software that works really well. The other big change is the simulation side of it over here, the offline programming. So we've got this basic version, which allows us to set up all the I/O, do a lot of our programming, and simple stuff, commissioning the machine and getting it running. And then we have a more advanced function called the Sim Advanced, where it allows us to do a lot of the 3D side of it. And probably the most important part is the Sim Advanced. This is fantastic. So if any of you are used to the older products where we had the Office PC, this pretty much replaces this. And I can run everything virtual on my PC or my digital twin. Okay, so a little bit deeper into the software components. The Windows model is kind of gone. We are switching over pretty much to Linux. Where did my cursor go here? Seems to have disappeared. There it is. So we have the Linux kernel, and then we have these instances, and these instances here are basically versions of software, and I can have many of these. I probably have 20 of these running on my system right now, so really great. And all these components here, this KOP stands for KUKA option package, allows me to add these packages. Like for today, we're going to be talking about conveyor tech. Safety, user programs, the whole tree that you're used to, all of that stuff is contained in this instance. Think of the instance as a Docker container or something like that, similar to that. And the simple folder structure that's here is this KUKA device manager now is a Explorer that runs on my PC, and I can go look at these files. So really good way to do this. Okay, so if we look at what pieces are here, and on a bigger level, we've got our core software and then our runtime. So if you're not familiar with the II, that stands for industrial automation or industrial intelligence, as you sometimes watch the YouTube videos. And KUKA is the abbreviated version of KUKA. And OS2 is our operating system. Over here on the engineering side, we got iiQWorks, and that consists of Sim and Cockpit. Those are the two that we're working on today. We won't do a lot with the App Builder. The App Builder is for the Smart HMI, or HMI Easy is what that's used for. That product is coming along. Okay, so if we look at the software components, I've got my engineering PC that's running over here and running my VRC mode and my instances with my KUKA device manager. I've got a real piece of hardware up here in this KUKA device manager. There is also one of those that runs on the controller, and you can see these two are identical. And then on my engineering PC, I can run my Office PC or my virtual robot controller. So that's what this switch is showing here. I can switch between the two. Done very nicely. Really like this software. So if we look at the Sim, some of you may have seen this for previous versions. It's showing the advanced 1.0 here, but we're on 1.1 already. And this is my virtualization, 3D virtualization. Some of the requirements on the left. It'll run on smaller PCs, but with all the instances, it does help to have a little bit more powerful PC and a nice graphics adapter. So that's what I'm showing on the left. So if we look at from what we've seen previously, many of you are probably familiar with the work visual side. We used to have this, and sometimes I even call the Sim the work visual. So pardon, I'm been at KUKA a long time, and I still use some of the old acronyms. So, and Sim is still there, and then we're removing this Office Lite and going to the virtualization of the VRC. So some of the features of the free basic still allows you to look at the 3D space, allows you to do some simple cycle time measurements with this RCS. And I can still configure my robot. I still need to be able to configure all the I/O, map all the I/O, and I can do this with the basic package. And you are limited on what you can do in the 3D world, as you'll see on the next slides. And the safety here is a work in progress. So our next release of software will have definitely a lot more safety modules. It's pretty basic right now, but there should be a new release coming out mid-month. Okay, here's the advanced. This allows me to do pretty much everything. Collision detection. I can import all kinds of objects that I want in the 3D world. I can do all the offline programming, pretty much a fully functional system, even taking advantage of the virtual world as far as visual components go, OPC UA, a lot I can do here. And then the CAD to path features. Grasp and release, many different things that I can do here in the advanced package. I will be using advanced all day today. So this is what the cockpit looks like, the software component that's downloaded from iiQKA. And you do have to have administrator rights to run this. But as you'll see later, I've got a great software repository and just lots of things I can do from the cockpit. The cockpit is considered more of a cockpit of my fighter jet that I'm running here, and that's where the name comes from. some of the things that you probably are used to. We will be using the Sim button here and the software repository, and pretty much all the packages come in here. No need to go find KOPs anyplace. They're all here. And future things with load and traces, I guess, are already there. And then probably the other most important one is the controller manager. It allows me to control my virtual robot and also the real hardware. All right, so we won't talk about App Builder today. I'm going to switch over to the controller here and show you what we're going to do. So we're going to attempt to build this cell today. So you'll see this is the Sim product here, and it's going to pick packages and drop packages. And this is a fantastic piece over here. The fact that I can log in locally and I can see my robot running a virtual pendant. I can start and stop it from here. Many things I can do. I'm basically seeing that same representation over here. And you can also see the robot running at the bottom here. So we're going to pick 2 packages and drop 1. So we'll create this here in a minute. We'll go through the steps. We'll spend our time today showing you how to do that. So just a nice, very nice simulation of the system running. And we actually can pick boxes and drop boxes, this grasp and release technique. So we'll start in KUKA.Sim here. And we're going to just bring in a CAD drawing, a 2-dimensional drawing, and I do have the advanced version here. And it'll bring that in here, and it should be already measured in. If I hit the import button, it should bring that in. But my origin is not in a very good spot, so I want to change that. I don't like that it's over there. So I'll snap it, and I'll move it. And I'm going to move it to where the center of the robot is. I'll zoom in a little bit here and try to find that center. I click on it, that should be the center. And apply it. And now if I look here, right now it's offset a little bit, so I need to reset both the X and the Y to 0 and 0. So I want to place a robot in that spot now. I've got my 2-dimensional drawing. So I'll go over and try to find the robot here. There it is, KR10 R1100, real small robot, 1100 millimeter reach. And it takes a second to bring it in. And once it comes in, if I double click on it, it'll go to a 0, 0, 0. If I just bring it in, it will not, it'll just plunk it on the page wherever I drop it. So I always try to go to 0, 0, 0. And there's my robot in the 2D world, or now it's in 3D. And you can see it jogging around here. So got lots of good controls in the 3D world. So I'm going to stick a conveyor in here. This is just a regular conveyor. I want to turn it by 90 degrees and see the little marks, tick marks down there. If I click on the 90, it'll go exactly to 90, not to 89.99. And I want to make this a belt conveyor. Got boxes, and I want my height to be around 400 millimeters because I have a small robot. And my length, I want to put whatever my drawing says it should be. Since I brought this in here, I think it's about 2 meters. We'll probably see that in a minute. And my width should be around 300 millimeters. So if I zoom out, you'll see that I have 300 there and about 2 meters there, 2,000 millimeters. So how do we want to snap that to the location. Sometimes it's a little bit tricky. You've got to zoom in, zoom out. So you see it's not working very well here. So if I zoom in, I think that does fix that problem. Let's try it here. You can see it's trying to snap. Sometimes you have to fumble around a little bit. Let's try snapping again and to zoom in. There we go. So now we're going to snap it to the center of where the layout showed me it should go. A little bit closer. I'm a robot guy, so the 3D CAD part sometimes trips me up. But as we're going here, now I need to add my other conveyor, and I first need to put a stop in here. So I want the boxes to stop in a certain spot. And it should automatically plug and play. That's what the PNP shows. And maybe I want to stick that around 200 millimeters off the edge of that conveyor. Or in world 640, I guess is the number. And I can try changing that to 401, but doesn't seem to work. It doesn't matter. It's only 1 millimeter. Okay, so next I'm going to need an actual tracking conveyor down here in this area, and I want that to be 1,200 millimeters long, 300 millimeters wide. So there happens to be a conveyor tech, an actual linear conveyor to use, and I want to rotate that by 90 degrees, and I'll use my tick marks there again, so it goes exactly to 90. And there's 95, there's 90. And again, I want to have, I want my height to be 400, and I want my length to be 1,200 this time, because that's what my drawing shows. So I'm going to just match it up with that. And it should be around 300 millimeters wide. Okay, and now I need to snap it again to the corner. So I'll move it around here. Also, I need to add a creator to create some boxes for me. So I will try to find that, and there it is. And I'll use the advanced creator, and now it'll plunk that in. And because I had plug and play set, it'll automatically connect it to that conveyor. But I still need some length and some height here. That should probably be 400 millimeters. Yep. And we'll attach it. That blue mark will attach it. And now I've got a creator. And I want to put some product dimensions in here. I want to have just one box. I don't need 5. I think the feeder will say 5 here. Yes. So I just need one product, and it's going to be green. And I would like 100 millimeters by 100 millimeters by 100 millimeters square box. Okay. And now I want to grab that conveyor and I want to move it around. I want to snap it. And I think you have to hold Control key and grab these together. Let's use the snap function and snap it to the center of that conveyor there. And I'll move my creator, and it should follow with it since it's already plugged together. And the next thing I want to do is I want to put a sensor out there. And this sensor is an important sensor because this sensor is going to tell me when that box arrives, and it's going to go into the robot's fast measurement input. And I want to locate that in a certain spot. That's going to be a little bit too far, so I think I need to move this around maybe 200 millimeters. Yeah, that looks good. And let's see, what is next? I think the next item that I want to do is I want to add a tool. So I already have a tool defined. If I can find it here. Where are you? Oh, not there. There it is. So there's my vacuum gripper that I've predefined. And there is, I created it from the actual vacuum cup that's already defined, the vacuum gripper. So now it's attached because I use the plug and play, and it works very nicely when you use these modules. So if we go to grippers, and there's the actual vacuum gripper, and I just adapted it. That's all I did. To save a little bit of time, it's now attached. All right, so we got our cell layout pretty much done. Next thing that we want to do is we want to turn that layout off. We don't need that anymore. We snapped everything to it. So I pushed that little I button there, and now all that extra mess is gone. Okay, so next thing is we want to start setting the system up. So the first things I need to do here is I need to add the options for conveyor tech. So I have these KOPs already pre-downloaded. You would use the Cockpit to do that. I'm not going to go through that today, but if I grab just that conveyor tech, it should grab all the associated items that go with that. So if you see here, I've got the conveyor tech module, and we're on 9.1.1, and then the UI creator, which is going to allow me to have this great HMI so I can see the pendant right from my virtual world here. And then it does need user tech. So we'll let it install that. Those options are there now. And I should have some extra items here. And I need to attach this conveyor now to the tracking. And you have to highlight the conveyor, press interfaces, and then you should be able to drag and drop those interfaces together. And it does support up to 5 conveyors. And we are using the standard KUKA resolver with RDC. So we'll select that and hit OK. And it is now connected. It came up with an analyzer that's going to connect some things together. It knows it has a position tracker, and all should be good now. Okay, next item here is to add the fast measurement signal. And oh, that wasn't the right thing to do. Sometimes they become disconnected. And all is good here, and best proposal. And now I'm going to click on that conveyor that I defined, and I need to enable the fast measurement signal. So this little gear here allows me to do that. And look at all the items that have now come up on the screen. So fantastic that all this stuff here is pretty much ready for me to fill out. So the work area has now popped up, but we'll get to that in a minute. Let's see where. I am looking for the fast measurement signal, and it is somewhere in here. There it is, right there. So that fast measurement signal will allow the trigger now to go into the robot controller, that switch that's out there. So if I click back on my robot again, there's signals. And now that I've added that, I'm going to take that sensor, and it's going to go directly to fast input number 1. And now it should be connected. And it is connected now. Great. And it's still connected. Fast measurement input 1 goes to that Boolean signal from the conveyor. I'll click on signals again to shut it off. And I think we're probably ready to program. Did I miss anything? Yes, I did miss some things here. What I need to do is set up my conveyor, because I didn't do that. It's got a very long 3,000 millimeter workspace, and this robot's never going to reach 3 meters. So we will change some of these values here in this work area. So we'll put this down to maybe like 400 millimeters, maybe 900 millimeters on alarm distance, and 1,000 on the length, since my conveyor is 1,200 millimeters already. And this little box here, I'd like to turn that on, and that's going to allow me to move, or sorry, first I need to change my origin. So I will move the origin so that it's right at the sensor. And there we go. And the other thing I need to do is go back to my conveyor, and I need to add a box. I need a box so I can see that part and I can program it. So how do I go about doing that? So I'm going to turn this on, but because I don't have a workpiece there or an object, I need to add an object. And none of those objects will do what I need to do. So I need just a simple box. And those boxes, I need to go hunt where I could find just a regular box, a 3D image of a box. Sometimes things are not so easy to find in here. Where would you suspect that would be? It's probably not in the fences. Probably not there either. Not in linear units either. Where is that at? We could ask Jules where it's at, but she probably doesn't know either. But we could ask her. I'll find it here in a second. Maybe she's taking a nap. She's not even hearing us. So. All right.
No, I am here.
Sorry. Just a little humor for you, Jules. She is awake. She is awake. All right. There it is. There's my block. Beautiful. Now I got a block in there. Oh, and it's quite large. So let's move that down to 100 millimeters by 100 millimeters by 100 millimeters. Okay, that's fantastic. And let's see if we can get that to appear on our conveyor now. So we go back to the cogwheel, and once we check or we select the block and we press the little checkbox there, like magic, there it is. Okay, and we can move that on the conveyor. Fantastic. That works really nicely. Not exactly where I want it, but we will fix that. So next part is to move that box around and to start programming. First thing we need to do is we need to set up some tools. Because we're going to pick 2 and drop 1, we need to define 2 tools. And the reason we have to define those 2 tools is we need to pick in different spots. So the first tool here we'll call cup 1. And it's not quite in the right spot. So we'll need to snap on that tool and define where cup 1 is going to be at. So we should have cup 1 defined here, and move around, maybe get a little bit closer so we can see that cup exactly where we want to place that tool, right in the center there. So we'll hit snap, and that little X there should snap that tool. Great. Snap function works extremely well. And that tool is defined there, and there's cup 1. Let's add cup number 2. That's going to be the front cup. So there's cup 2. And we're going to snap that to the center of that cup. So that's tool 2. And all should be good. So that's how we define our 2 tools. Tool 1 is cup 1. All looks good to me. I bet it looks good to you guys too. So let's look at cup 2. All looks good there. And the other item that's here is the conveyor scene. And that kind of already got all set up for us. So the next step here is, since we got both tools defined, is to start programming. And to do that, we are going to go to the Program tab up on top, and we need to select our robot. So if we click on the robot, it should show us our programs. And perfect. So right now we have the main program that's there by default, and we're going to add a program, and we're going to call this Conveyor Tech main, the main program. So we'll need a main program and 2 separate programs for our picking of each of our parts. So there's main, and it puts the home and home in there. We're going to add another one, and we're going to call this Conveyor Tech run 1. We're going to have run 1 and run 2. Those are going to be our names. Okay, we'll go back to the main program and maybe teach our home position or change our home position a little bit, or just change some positions in general. So to do that, we interact with the robot and we jog it. That's not the right way. So let's try just putting a fixed number of 90 in there. We'll get rid of all the values and put in 90, and now we'll have a perfect 90 degrees. And well, let's try to put 90 in there. There's 90. And now we won't be in any singularity problems. So I can jockey the robot around here and use these green and red arrows to move it around to where I want it. There are other ways, and that should teach a point. So now point P1 is taught. And I don't like that name particularly. I want to call that wait pause for wait position. And that should now be changed. And I want to use cup number 1, the tool cup 1. That should be okay. And I'm going to jog it around a little bit here. And you can see one great thing about the teaching menu here. If we look here, we see point-to-point, Lin, circular, and then this is the touch-up key. And that's enabled by pressing this button right here, this Teach Overlay menu. It works extremely nice. I like it. You can also right-click on the item over here and teach the point that way. So several ways to do it. Now that point should be touched up, and I've got the right tool value. Okay, and the other thing I want is I want to put a loop and end loop. You can go into KRL and type these in, but just as easy to put the loop and end loop. And now I just move that position up into the loop and end loop. And now we have home. Some other things that we might want to do here is put some structure in here. So that conveyor tech init. So there's 4 commands there. And we'll need to initialize the conveyor tracking to start out with, and we need that statement in there. So based on the option packages that you add, it will change the menus that are up here. It works extremely nice. Okay, so the next thing we're going to add here is we're going to add an output. So we're going to turn the output on. Or actually, at the beginning of the program, we want to turn all the outputs off. So we're going to turn that to false to begin with. And we can copy that statement and paste it and change the number to number 2. So now we turn both outputs off to begin with to make sure there's no product in the conveyor or on the gripper. And now we've got those 2 statements there. And we're just going to paste this down here because we'll probably need this later. After we drop our product off, we're probably going to want to turn our outputs off again. So we'll put those in there. Okay, so there's our wait position that we've got defined in our loop. And I would like to add another point here. Or first I want to add the run in here because after I'm at the wait position, I want to run the program called CT run 1, which is conveyor tech tracking run 1. I want to pick up that first part. And that's in there now. And I want to teach the outbound conveyor now. So let's try to jog the robot over there. And another nice thing here is you'll see the, I'll show it in a second here. Yeah, so you see this bar that's up here. If I touch on that bar, it'll go to even increments, so I don't have these decimal points come up here. So if I just let it go forward here, and if I'm on that, it should go to an even increment. It looks like it did not. All right, well, you'll probably see that later here. Okay, so now I've got a point called P2, and I want to change that name, of course. I want to call that something more descriptive in my program. How about something like place pause? That's a much nicer name than P2. And do I have the right tool selected? It looks like I do. And the robot automatically jumps over there when I press it, and then it goes to my place position. And the place position, probably okay, but we can maybe jockey it and move it around a little bit. And that's better. And what should the correct height be here? I think my conveyor is 400 millimeters high. So I should probably be about 500 millimeters high or so. A couple different ways to do it. Not sure what's the best way. We can cheat here and type in 600. I don't think that's the right number, but we're probably too high there. And we'll move a little bit and touch it up again. Because that point is not taught right now. And we can right click on it and hit touch up. So now it's taught in that location, but I don't think it's right in the Z value. So let's go back over to the inbound position here, or the weight position, and find out the right Z value. And if you noticed here that when the bar came up here, I went to an even increment. So right now it's at 575. It's because I used the little bar that was on the side to find that exact location. Okay, so now that's taught at 575, so 75 millimeters above the part. I'm going to be waiting. And let's go back to the place position and let's set the proper 500. And I'll touch it up, and it's now touched up. The other one's at, so it should drop it right at the right location. And do we like the X and the Y? I think everything looks good there. Next thing is we're gonna go, we're gonna add oops, what am I doing here? Let's see. There's the weight position. And I'm going to double click on the run one program and create this. So I can delete these positions that are in these home positions. I don't really need those anymore. I'll add some positions in here. I'll be needing probably 3 positions, an approach position. And one important thing here is that these need to be changed to the classic type. We can't use a standard spline in here. So they must be, you see these home positions have splines. These have to be the classic, otherwise they don't function properly. So, and for this program, I want cup 2 because I want to pick with cup 2 the first time. And I need to make sure I get my tool and base set correctly to begin with. Otherwise, my other positions will be off. So this is a little bit clunky at times. I guess I do have the right tool set, but my tool is not orientated properly. So that's the orientation I would like to have. I have a different orientation here. So if I touch this point up, I can use the button there to touch it up, and I still have the wrong tool, and I don't have the right base set. So let's see if I can fix that now. There are some easier ways to teach these points, but I want to show you the difficult way. I'll show you a little bit later on how that's done. So let's jog this to the right spot, and let's get the let's orientate the tool. And I'm going to use these markers again. You see how I can change this value here, and it goes to even increments. So really handy feature to have. So now it's nice and straight. All right, we got everything set. Let's try it one more time. I like that location, kind of center of the gripper or center of the conveyor. And I need to align the second gripper up, but my tool is still incorrect. So I need to fix that. I think that should be tool 2. Or cup 2. All right, I think we're going to finally get it straight this time. And it's touched up. And we need to add some more things to this program. So we need to turn the tracking on. So in the beginning of this program, I'll always need a tracking on and a tracking off. So when I grab this part, the track will turn on, and then after I pick it up, the tracking will turn off because I'm no longer tracking on that conveyor. So that's what these commands here are. So I'll put that right there, and I need to select the conveyor. Sometimes that turns off, And then the last thing I'll need here is I'll need to turn the tracking off. So you see these 4 different commands here: the initialize, the running of the program, tracking on, tracking off. So we just need those 4 commands. So very nice and easy way to do it compared to the older way. It was much more work. And we want to have trigger mode. We want to trigger on the sensor. Okay, so we'll go back to this position. And I think everything's good. Now I just need to touch up the point so that, that I'm on the box. So to do that, I want to move the box because that's actually where it gets triggered. And I need to adjust that point. And how do I do that? So I'm going to zoom in a little ways. And notice the little trick here, and not trick, just another way to do it. I grab the pink center here, and now I'm going to snap it to that box. And you can see that the whole robot and everything moves together. This is the preferred way to do this. So now I snap to center that box. And then, of course, I want to touch that point up. And if I right click there, oops, now I can touch it up. So P1 is now taught there. And I'm going to need some other approach positions. So I need to create some more points. Oops, I need a lin point, not a point to point. And now I've got 3 more points in there. And I could change the names, but I'm going to just leave them as P1, P2, and P3. And what I need to do now is turn an output on. Or sorry, I need to grab the part. So I want to turn output 1 on here. Okay, so these positions are all the same, so I need to modify them. And if I want to, what I can do is just add another 50 millimeters, and I can simply just come in here and do that by adding 50. So I have now approach position, so plus 50 will move that point up. And if I hit touch up, or I do that to my other point, my depart position plus 50, they are taught. I don't actually even have to touch them up. So really good way to do that. Okay, moving on. What's left here? So I like those positions. I turn my output on. And now I want to duplicate this program. All this work that I did, let's do this for now tool 1. So if I copy it and paste it, and now I have another program here, and we'll change the name of that. And you guessed it, we're going to call it number 2. So rename, and we go on the right property on the right-hand side. I guess we can do it right in here because we duplicated. Okay, so now what's in there should be a duplication. And sometimes these programs don't display right. I don't know if this is a bug or a problem, but I have to fiddle. You have to press the button a couple times. Okay, so there's our main program. We're going to select it, and we should be able to. We have to select it and activate it. Now we can touch it up. All right, one more time here. Let's try it. There we go. Okay. But the difference here is we need to change our tool value is wrong, and we need to pick up on the other cup. So now we're going to modify these points here to do that for us. So this needs to be tool 1 on all these points. So if we change this to cup 1, and you've got a cursor up, there we go, cup 1. And it just so happens that that works out perfectly, and everything should be good. And we have tool cup 1 set, and we should be able to touch that guy up. Okay, wrong tool. So let's change that to cup 1. And now we have the correct tool. And we need to touch that point up. Okay, it's taught up. It's got the right tool. It's got the correct base. And rinse and repeat one more time. And we should have our last one done. We need to touch that point up. Okay, I like it. And is our output right? I think that is the correct output, but maybe our other program is incorrect. We have all this right. Well, it all looks good to me. We turn our output on to pick it up on cup 1. I think this guy is actually incorrect. Yes, that should be output number 2 for tool 2 or cup 2. Okay, all set there. All right. Will it work? It's a big question now. We need to add one more. We're missing one more function here. We need to call tool 2 or the cup 2. So we'll stick that in there and change that name. And this is where we change this to number 2. So now it should call that subroutine number 2. Conveyor tech run. Okay. One last thing we need to do is the I/O mapping. We need to map a physical signal. The grasp and release should function on its own quite nicely, pretty much out of the box, but we need to physically map output 1 and 2 to some physical, not physical hardware, but hardware that are physical inputs and outputs. They're in virtual. So we need to map output 1 and 2. Otherwise, it will not actually pick the boxes. It'll go near them, but it won't actually pick them. So on our X48, we have an I/O board, and we're going to cheat a little bit, and we're going to go to those physical outputs here and map 2 of them. So we need to find them on the right-hand side. So the I/O mapping is a little bit different than in WorkVisual, but it functions very similar. And I think we can just drag and drop these over. And drag them to there, and it should automatically connect them. And they should appear in our list. You see that they're down here now in our list. And those signals automatically got taken, and those should allow us to pick and place our box. They are set and they are defined for us. I think that's all we have to do. Yeah, there they are right there, 1 and 2. So on to the next part. Let's try running and see if that works. So if we move on to the next section and we reset and run our program. Oh, one thing I missed. Yes. So one problem here is you see the difference between the spline output here. These must be classic signals here. So this is a SPTP, and it won't run if that's set. So we'll go ahead and change that. I think I missed that. All right. And another thing we'll do is we'll define our initial position. I think the robot moves straight up. We don't need that. We'll save that. So that's our initial position. And now we're ready to. So what's happening here is there's 2 modes. There's the RCS mode and there's the VRC mode. The VRC mode is a virtual robot controller here. And we're going to be running this locally. So we have a local host, and our instance name is Conveyor Tech Instance. So that's going to be running in the background in our cockpit. So we will start this back up, and you can see the different modes there. We'll keep it on that. And the other thing is the UI should pop up. You probably saw that earlier. So I'm just going to jump forward a little bit here so we don't have to wait for this. Let's try that one more time here. There we go. And I'll bring my HMI here up in a second. Okay, so you see that I've got this extra box here, this extra orange box. I want to try to remove that box. So if I double click or click on that, it'll remove that box. And you can see that I'm missing a couple boxes. My conveyor is moving a little bit faster than what the robot can move. So we can go in the settings here and try to change that. Maybe we change the speed of our conveyor, and we can do this while it's running and prove, how fast we can move those boxes. I don't think that's quite right. We're still missing some boxes. Let's look at the creator and see what values are there. Maybe change this down to 250 millimeters per second. Does that do it? It does not. Okay. So the problem is our boxes are coming out pretty quick. So let's click on the creator and let's change the speed here. Yeah, so we're going to put have the boxes come out a little bit slower. So now they should come out slower as soon as that's active. Yeah, and they do. So now we can easily track that and drop it. And I think that's about all I have for today. If Jules, are we ready for some questions? I don't think there's anything more that I want to show. That's one second before we do that. Let's take a look at just some views here. You can kind of see it from different spots that it's running. And I think we're at the end. Do we have some questions?
Awesome. Thank you, Chad. Yeah, just to give it a minute here, if you want to throw in any questions you have in the Q&A or the chat box. But we do have one that came in. Conveyor Tech has 4 commands. Are other tech packages the same?
It depends on the tech package. This tech package is undergone a lot of changes because the old one I thought was tough to use, and the template that was there wasn't so easy. So this one has 4 commands, and as you can see here, they're pretty straightforward on what they do. So the best thing is to try them out. You can try this app example out and see how you like it.
Awesome. Thank you, Chad.
I hope that answers the question. I think it does. Go ahead.
What are the best features of iiQKA.os2 or iiQWorks?
Oh, glad somebody asked that question. So definitely the best feature is to have the digital twin. The fact that I can have a real robot controller running. And let me just show that screen here. I think this is it here. Yeah. We will just make this just a little bit bigger. So this is a fully functional controller, and you can see it's in auto now. I can see all the different menus. I can see my program that's running here. This should be the program that's running. And it also shows me, well, because I'm in auto here, maybe I need to switch this. Okay, so another cool thing here is notice how it's telling me that I don't have single point of control or this Spock. And the reason I don't is because Sim is in charge right now. So if I switch this to T1, which it won't let me do because I don't have Spock, and I will get Spock. This allows me to get Spock. Now I have single point of control, and now I should be able to switch to T1. And let's see, let's go to my 3D view here, and there's a view of my robot. If I move around here, I can see that robot in the real world on my pendant. I can jog from here. All my menus are similar, not exactly the same, but very similar. All right, that was kind of a long-winded answer for that, but did I answer the question? The digital twin is the best feature of it in the HMI.
Awesome. Could you bring in your KRL code from 8.x software?
Yes, excellent question. You can do that. We've been successful with several customers doing this. One thing that does not work is older SIM files. Those do not work. But there is a way to import KRL. So let me switch over to a lot of things open. Let's see, where are you? Yes. So what you can do is in the program menu here, And if I click on my robot and I right click here, I can import directories or files. So yes, you can bring them in. Older KRL commands, or sorry, older conveyor tech commands will probably not work. It depends on the package. So not 100%, but most KRL stuff will come in. And the motion statements are a little bit different. There are a couple caveats there. So, all right, next question.
Sounds good, thank you. How do you manage multiple robots working on the same conveyor line?
Okay, good question. So what happens is there's this handy, I don't know if I went through it very thoroughly here, but for every robot, there's this button here. And when I press this button, it'll display specific information about that robot. So RoboTeam is a common package that we would have. So if we had another robot in here, we would simply click on this button here, and it would show us the details of that robot. Exactly how all that's going to work, I don't think has been determined because the RoboTeam package is not out yet. So whoever asked that question, good question. All right,
thank you, Chad.
We got a couple minutes left.
Yeah, just a couple minutes. We have another one here. Is it possible to set the robot safety configuration through Sim?
Could you repeat the question?
Is it possible to set the robot safety configuration through Sim?
Okay, good question. Yes, and we do that through the Devices tab down here. You can still see my screen, right?
Yes, we can.
Okay, perfect. So the safety configuration is done down here. It's a little bit bare right now. Let's see if we click here, do we see it? Rules-based. Yeah, it's done. It's done here. Let's see if this works. Yes, here it is. So it's similar to how it was done on the iiQWorks controller, in that I can have ands and ors. They call this the Argus safety system. So we're stealing that Argus safety system, and we've kind of brought it in here. So this is how it's done in this tab, in the Devices tab. Excellent question.
Awesome.
Where is it? Yeah, right here. Okay. We got 1 minute. Can we squeeze one more in, Jules, or no?
I think we can. We can do it. We have one more here.
Don't be selective now. Give me.
This user says they're new to KUKA. They use other robot sims heavily. When you say digital twin, this means online edits. Can you explain this a little bit?
Yeah, online edits. Yes. This is not 100% figured out, I don't think, but let's go back to program here and let's click on our robot. So we have these other views here. So the controller view, we didn't really talk about that, but the controller view gets me to a real controller, and then this remote view allows me to connect remotely or online. Since this is still a new product and new software is coming out, this is evolving. So this will get better and better. But remote view does work fairly well, but it'll be better in the future. I'll also allow you to change programs from here and send that one program. Today, that's not available, but there's a new release coming out. We'll probably have that feature. Trust me, I'm asking for the same things you guys are asking for. All right, we got 12 o'clock right now.
Yes, we do.
Not going to get one more in, are we, Jules?
No, that's all the questions we have right now. So
I'll try to talk less next time. How about that?
No, you did great. All right, well, that brings us to the end here. Thank you again, Chad, for being on the session, and thank you to everyone in the audience for joining. If there are any additional questions, please feel free to reach out. Thank you,
Jules
guys.
gets all the other questions, not me. She gets them, not me. Thanks, guys.
All right, bye, guys.
Making automation easier.